Welcome you all my lecture series of machine learning. In today's we are going to see the topic on decision tree using the ID3 algorithm. So decision tree belongs to the supervised learning method. So in the previous session, we have seen what is the k nearest neighbor, how the particular new class label is predicted using the k nearest neighbor algorithms. In today, we are going to see that how we can classify that the particular classes using that ID3 algorithms. So, for example, in the real world scenarios, we have the several applications like medical diagnosis decisions and loan approval decisions and customer behavior predictions and risk assessment. So these are all the real world scenario. So we are going to find out, for example, whether the particular student is pass or not. So what is the term we are going to use? First term is first வந்து we based upon that whether the particular student internal mark is greater than 50 means the first constraint. Next, we have to check before the internal mark. First, we have to check whether the particular attendance percentage of the particular person students is greater than 75. Once the attendance is greater than 75, only he is eligible to return the exam. So the attendance is greater than 75. After that, the internal mark of the particular students is greater than 50, and also the study hours of the particular student is greater than 5 hours per day means confirm the particular student is pass. So based upon that particular attribute, we have to decide the particular student is pass or not. So these are all the decision making attribute. We have to find out the new class of the class label of the particular data. So in that classification, they are using that ID3 algorithms using the decision tree method. They are classifying the new class labels. So in the decision tree, we have the several types of algorithms. So the ID3 is one of the algorithms. So in the ID3, how we can do the particular correction means in the ID3 algorithm, first we have to, our main objective is we have to build the tree. So it is a tree-like structures. Based upon the tree-like structures, we are going to predict the new class labels. So what are all the classification challenges means how to make the decisions from the particular data. Okay, first thing, how to make decisions from the data and which attributes we have to split up and how to measure the attribute importance. These are all the challenge in the classifications. So how we can make the decisions from the particular data and which attribute is a very important attribute. So based upon that, we have to build the tree. So the decision tree, we have to build that it is tree-like structures. In the tree-like structures, we have to, using the tree-like structures, we have to predict the output. For example, in the right side, you have the tree. On the tree as it is, we have the root node and we have the internal node and we have the leaf node. The root node is the first node of the particular decision tree and the internal node is the connected to the deeper nodes. So this is the way the tree is built. So what are all the key concept in the decision tree means root node, that is a starting point. Next we have the internal node, that is the branches of the particular tree. Next we have the branches, that is a path of the particular tree. Next is the leaf node. So these are all the basic key concept in the decision tree. So we have to split the attribute based upon that particular decisions. So our main objective is we have to select which attribute how most important. So that attribute comes to the root node. So how that ID3 algorithm is process means first we have to calculate the entropy of each attribute, and second thing we have to compute the information gain of the particular attribute, and third one we have to select the attribute which has the highest information gain, and third after that we have to split the data set recursively. So we have to first step we have to calculate the entropy of whole data set, and we have to calculate the entropy of individual attributes. So from the entropy calculation, next we have to find the information gain of each attributes. So for example, here we have one example. In that example, it is that we have to predict whether the particular based upon that climate situations, we have to predict that whether they are playing the tennis or not. So the climate situations, like we have an outlook, temperature, humidity and wind. Based upon that, we have to find out whether the climate is hot or cold, a wind or thing. So wind and humidity, based upon that we have to find out whether the tennis will play or not. So first step, we have to find the entropy of whole data set. So entropy of whole data set, how it is calculated means the probability of plus and log of probability of plus minus probability of minus and log of probability of minus, that is the entropy of particular attribute. So first step, we have to find out the entropy of whole data set, means number of yes or no. So number of yes means probability of plus, occurrences of probability of plus and occurrences of probability of minus. So based upon that, the entropy is calculated. After that, information gain is calculated of every attribute. For example, the information gain of outlook, information gain of temperature and humidity and wind is calculated. So we have to select. So what is our main objective? We have to select which attributes comes to the root. So which information gain is highest means that attribute is comes to the root. So in our data set, the outlook have the highest information among the three. So the outlook comes to the root. After that, we have the branches like humidity, then then temperature and wind. So this like the decision tree is built. So after constructing the decision tree, we have to predict the new class labels. I hope you will understand how that ID3 algorithm is processed. So we have to calculate the entropy and information gain, and based upon the information gain, we have to find the root of the decision tree. Thank you.